Hey there, future engineers and technologists, and welcome to today's Explainer. Now, what we're looking at today isn't just a history lesson. It is literally a blueprint of our industrial past that is directly shaping the future you're going to build. We're going to explore the evolution of impact, going all the way from the raw, gritty power of the very first steam engines to the incredibly advanced, harmonized tech of Society 5.0. So here's what we're looking at on the agenda today. First up, the British Industrial Revolution fallout. Second, Industry 4.0 versus Society 5.0. Third, the ESG framework challenge. And fourth, we'll wrap up by asking, does tech actually improve human life?
All right, let's dive right into Section 1, the British Industrial Revolution fallout. If we zoom in on 18th and 19th century Britain, we're basically looking at ground zero for our modern environmental crisis. I mean, just look at the staggering urbanization of London here. Back in 1801, the population was roughly 1 million people. Fast forward to 1901, and it had skyrocketed to 6.6 million. But you know the real metric you need to pay attention to here? By 1880, there were 3.5 million fireplaces, and absolutely all of them were burning coal. This totally unchecked engineering and insane population growth eventually culminated in the lethal Great Smog of 1952. What happened was a cold fog moved in and trapped that immense, unbelievable amount of coal smoke. It created a smog so incredibly thick that driving was impossible. People literally had to cancel indoor concerts because the audience couldn't even see the stage. Tragically, this event killed over 4,000 Londoners in just the month of December alone.
The sheer ecological cost of that era is just staggering. You can see the stark visual contrast before and after severe urban air pollution took hold. Burning all that coal produced massive sulfur dioxide emissions, which in turn bred acid rain. And that acid rain did tremendous biological damage. It actually leached massive amounts of aluminum right out of the soil, which was this hidden, creeping toxin that started killing off the fish. It darkened the stone and the vegetation so severely that it literally forced evolutionary mutations in moss and insects. Scientists actually call this phenomenon industrial melanism. It's wild to think about.
So how exactly has the paradigm of pollution evolved since then? Well, the past gave us these highly visible, very localized threats, right? Thick coal smog, raw sewage dumping directly into the River Thames, and massive physical deforestation, mostly because they drained their timber stocks to build 19th century naval ships. But our present-day Industry 4.0 challenges, they're often completely invisible and honestly far more insidious. We're talking about global carbon emissions, widespread digital isolation, and the silent, deadly leaching of toxic heavy metals from techno-trash straight into our groundwater.
Okay, because I know how fiercely competitive you engineering students can be, I've integrated some rapid-fire, gamified quizzes to test your attention today. Time for our first knowledge check. Lock in your answers. Question 1. What weather event killed 4,000 Londoners in December 1952? Question 2. What toxic metal does acid rain leach into water that proves fatal to fish? And question 3. What natural resource was completely drained to build 19th century naval ships? Got your answers? Let's see how you did. The answers are the Great Smog, aluminum, and timber or woodlands. Excellent job if you went 3 for 3 there. Grasping the raw ecological cost of early, unchecked engineering is absolutely vital if you want to avoid repeating those exact same mistakes in your own designs. Moving right along, let's jump into Section 2, Industry 4.0 versus Society 5.0.
If we map out the massive leap into the modern era, we started way back at Society 1.0, the hunting society. We moved through the agrarian and industrial phases and eventually landed in Society 4.0, which is the information society driven by computers and the internet. But you know, as future engineers, you aren't just coding for basic information processing anymore. Your task is much bigger. You are tasked with building Society 5.0, the super smart society powered by AI, IoT, and total digital transformation.
To really break down the difference here, let's look at the core goals. Industry 4.0 is entirely about how to work smartly using computerized communications and highly effective automated machines. It's really all about raw machine efficiency. But Society 5.0, that is a massive philosophical upgrade. The goal here is optimizing man-hour responsibility. It focuses entirely on the knowledge worker. The method isn't just about automation for automation's sake, it's about harmonizing intelligent tech for the ultimate benefit of human workers and society as a whole. It's a real game changer.
All right, it is time for our rapid-fire quiz 2. Ready? Question 1. Which paradigm focuses heavily on computerized communication and automated machines? Question 2. Which paradigm aims to harmonize technology specifically for human benefit? And question 3, what is Society 5.0 also known as? Here we go. The answers are Industry 4.0, Society 5.0, and the Super Smart Society. If you got those right, it means you understand that building the future requires far more than just raw coding. It requires a deeply practical, ethical framework for decision-making.
Which brings us perfectly to Section 3, the ESG Framework Challenge. Now, this framework right here is basically the ultimate operating system for modern technologists. ESG stands for Environmental, Social, and Governance. And let me be clear, this isn't just fluffy corporate jargon. This is your actual blueprint for the future. Modern engineers absolutely must integrate these considerations into their technological development and their corporate risk management. It is literally the only way we ensure true sustainability and prevent the kind of staggering ecological disasters we saw back during the Industrial Revolution.
So let's apply this ESG framework practically using the 3R concept: reduce, reuse, recycle, but specifically aimed at techno-trash or e-waste. As engineers, you've got to reduce by designing energy-efficient technologies with sustainable materials. You have to encourage reuse to avoid those completely wasteful, constant consumer upgrades, and you absolutely must recycle because techno-trash is the single fastest-growing type of waste on the entire planet. We have to keep heavy metals like cadmium, lead, and mercury out of our landfills. And from a governance standpoint, that means utilizing and actively partnering with specialized e-waste processors like GreenDisk to handle that disposal safely and effectively.
Because the real-world stakes here are massive, guys. Improper disposal of techno-trash creates a highly dangerous bioaccumulation of toxins. Think about it. If toxic materials leak into the ground, they contaminate the water we drink, the plants we eat, and the animals that live in that ecosystem. And if you eat an animal that has been contaminated, you're getting a double dose of toxins that your body cannot easily process. That leads to nausea, vomiting, and even long-term cellular damage. As designers, you literally have to think about the entire end-of-life cycle of your creations.
All right, quiz 3 is coming in hot. Think back to those hazardous elements we just talked about. Question 1, what does ESG stand for? Question 2, name 2 toxic heavy metals commonly found in e-waste. And question 3, what is currently the fastest growing type of waste in the world? Boom, let's check it. The answers are environmental, social, and governance. For the metals, any of these will do: cadmium, lead, or mercury. And the fastest growing waste? That would be techno-trash, also known as e-waste. Recognizing and planning for the impact of this e-waste is your very first non-negotiable step in engineering a sustainable Society 5.0.
Okay, final module today, Section 4. Does tech actually improve human life? Stepping back to elevate our perspective a bit, we need to analyze this dialectic really closely. Technology has a profound and honestly sometimes terrifying dual impact. It's a total double-edged sword. On the positive side, we have worldwide virtual laboratories that allow global experts to collaborate instantly, which heavily reduces the environmental impact of travel emissions. We have automated, smart sensors that respond to human presence, just automatically turning off lights to save power. But flip that coin, and we face severe biological and social costs. Technology addiction leads to highly sedentary lifestyles, triggering obesity and physical ailments like carpal tunnel syndrome. We see massive ecosystem disruptions happening just to clear land for new manufacturing plants. And socially, we face a digital landscape that is completely plagued by viral misinformation.
Time for the final, gamified quiz of the explainer. Let's lock in these real-world pros and cons. Question 1. What technology enables experts globally to collaborate without producing travel emissions? Question 2. Name a physical health issue stemming from tech addiction. And question 3. What automated technology can be used to reduce power waste in an empty room?
Let's confirm those final answers. We have virtual laboratories. We have obesity or carpal tunnel syndrome. And we have smart sensors. Huge congratulations to all of you focused learners who locked in those correct answers today. Being able to synthesize this kind of dense, complex impact data is exactly what separates average coders from truly visionary engineers.
Before we wrap up, I want to leave you with this really powerful, anchoring thought to chew on. Quote, do our devices bring us together, or are they separating us? Are we more connected to knowledge, or just more likely to believe misinformation? Unquote. We have to constantly question the true value and the deep psychological cost of our constant digital connectivity. New technology definitely helps optimize our world,
but it doesn't automatically optimize our well-being.
And that brings us to the ultimate question. Ultimately, as future engineers, technologists, and the very architects of Society 5.0, will the technology you design make life on Earth better or worse? The blueprint is entirely in your hands now. Thanks so much for joining me on this explainer today. Keep building and always keep questioning.